Was Earth once a giant ice cube? The terrifying truth of Snowball Earth. When we think of the Earth, we think of a cradle of life, a warm, wet, and blue sanctuary in the cold vacuum of space. We are accustomed to the idea of ice ages, those periods where woolly mammoths walked across frozen tundras and glaciers crept down from the north. But there is a theory in geology that suggests these familiar ice ages were merely a light frost compared to what happened 700 million years ago. Imagine a time when the ice did not stop at the temperate zones. Imagine a time when the glaciers kept moving, relentless and crushing, until they met at the equator. This is the story of Snowball Earth, a period when our home was arguably the most hostile place in the solar system. A solid ball of ice floating in the dark dot. To understand this phenomenon, we must strip away everything we know about the modern world. There were no animals, no plants, no forests. Life existed only in the oceans as microscopic, single-celled organisms. The continents were not in their current positions. They were clustered together in a supercontinent known as Rodinia. It was on this alien stage that the greatest climate catastrophe in history played out. The birth of a radical idea, the concept of a snowball Earth, was not always accepted. For decades, geologists believed that Earth's climate had been relatively stable, fluctuating only slightly. The idea that the planet could freeze over completely seemed physically impossible because of the albedo problem. Ice reflects sunlight. If the Earth became too covered in ice, it would reflect so much solar energy that it would never be able to warm up again. It would remain a frozen block forever. However, clues began to emerge from the rocks that contradicted this stability. In the mid-20th century, explorers and geologists like Sir Douglas Mawson in Australia began finding strange geological formations. They found dropstones in ancient sedimentary layers. Dropstones are large rocks that had been carried by glaciers and dropped into the mud at the bottom of the ocean as the icebergs melted. Finding these as evidence of glaciation, the shock came when paleomagnetic studies, the science of reading the magnetic alignment of ancient rocks to determine their original latitude, revealed that these dropstones were deposited not at the poles, but near the equator. This presented a terrifying paradox. If there was ice at the equator, the warmest part of the planet, then the rest of the world must have been frozen solid. In the 1990s, geologist Joseph Kirschvink coined the term Snowball Earth to describe this scenario. And later, Paul Hoffman and Daniel Schrag expanded the theory, suggesting that this total freeze happened not once, but at least twice during the Cryogenian period, roughly between 720 and 635 million years ago. The trigger: how to freeze a planet. How does a planet with a hot molten core and a sun beaming down on it turn into a block of ice? It requires a perfect storm of geological mishaps. The leading theory involves the breakup of the supercontinent Rodinia. As Rodinia broke apart, it created massive new coastlines in the tropics. This increased the amount of rainfall and weathering of rocks. When silicate rocks weather, a chemical reaction occurs that pulls carbon dioxide out of the atmosphere and locks it away in ocean sediments as carbonate rocks. Carbon dioxide is Earth's thermal blanket. It traps heat. As the weathering of Rodinia accelerated, it stripped the atmosphere of this greenhouse gas. Simultaneously, there was a massive eruption of basaltic lavas. Usually, volcanoes add CO2, but these lavas weathered rapidly in the tropical rain, sucking even more carbon out of the air. The Earth began to cool. The polar caps expanded. This is where the positive feedback loop, or the albedo effect, kicked in. Ice is white. It reflects the sun's energy back into space. Dark ocean water absorbs heat. As the ice expanded, it reflected more heat, making the planet colder, which made the ice expand further. Climate models suggest that once the ice reached within 30 degrees latitude of the equator, the process became unstoppable. The runaway icehouse effect took over. Within a geological blink of an eye, the average global temperature plummeted to minus 50 degrees Celsius. The oceans froze over with ice sheets kilometer thick. The hydrological cycle, rain and evaporation, essentially shut down. The Earth died. The silent planet tried to visualize the surface of Snowball Earth. It would have been a place of blinding brightness and deafening silence. There were no crashing waves, for the ocean was capped with ice. There was no sound of wind rustling through trees, for there were no trees. The sky would have been clear and cold, with the sun appearing smaller and more distant than it feels today. Underneath the ice, the oceans became anoxic, deprived of oxygen and stagnant. The flow of nutrients stopped. For the microscopic life that had ruled the planet for billions of years, this was the apocalypse. Photosynthesis became nearly impossible as the thick ice blocked out the sunlight. Most lineages of life likely perished during this time. The biological diversity of the planet was pruned back to the barest minimum. However, life is stubborn. We know life survived because we are here today. The question that has puzzled scientists is, where did it hide? There are two main schools of thought. The first is the hard snowball theory, which insists the ice was thick and total. In this scenario, life survived in small refuges. Perhaps they huddled around deep-sea hydrothermal vents, feeding on the chemical energy spewing from the Earth's interior, indifferent to the freezing world above. Or perhaps they survived in small pockets of liquid water within the ice itself. Or in subglacial lakes like modern-day Lake Vostok in Antarctica. The second theory is the slushball Earth. Some scientists argue that the freeze wasn't total. They suggest that a band of open water, or at least thin, slushy ice, remained around the equator. This would have allowed enough sunlight to penetrate for algae and cyanobacteria to continue photosynthesis, keeping the food chain barely alive. The great thaw, the ultra-greenhouse if the Earth was stuck in a frozen state where it reflected almost all the sun's energy. How did it ever unfreeze? The savior of life on Earth came from the most destructive force we know, volcanoes. Even though the surface was frozen, the Earth's tectonic plates were still moving. Volcanoes continued to erupt, punching through the ice sheet and spewing ash and gases into the atmosphere. In a normal climate, rain washes carbon dioxide out of the air. But on Snowball Earth, there was no rain, only dry, freezing static. There was no liquid water to dissolve the CO2, and no rocks exposed to weather it away. So, the carbon dioxide began to build up. It accumulated for millions of years. Levels of CO2 rose to staggering heights, perhaps 350 times higher than today's levels. It took a long time, but eventually, the greenhouse effect of this massive CO2 blanket overcame the reflective power of the white ice. The melt, when it came, was violent and rapid. As the ice retreated, the dark oceans were exposed again, absorbing the sun's heat and accelerating the warming. The planet swung from a deep freeze to a hothouse, almost overnight in geological terms. Temperatures may have soared to 50 degrees Celsius. Violent hurricanes, fueled by the extreme temperature differences and massive evaporation, scoured the continents. The melting ice caused sea levels to rise hundreds of meters. This chaotic transition is recorded in the rocks as carbonates. These are thick layers of limestone that sit directly on top of the glacial deposits. They formed because the atmosphere was so thick with carbon dioxide that when the rains finally returned, they were essentially acid rain. This acid rain aggressively weathered the exposed rocks, washing massive amounts of calcium into the ocean, which precipitated out as rapid layers of carbonate rock. It is a geological signature of a planet trying to regain its balance. The aftermath, The Cambrian explosion, the most fascinating aspect of Snowball Earth, is not the freeze itself, but what happened immediately after. Following the final retreat of the ice around 635 million years ago, the fossil record changes forever. Before the freeze, life was microscopic and simple. After the freeze, we see the sudden appearance of the Ediacaran biota, large, complex, multicellular organisms. Shortly after that, the Cambrian explosion occurred, giving rise to almost all modern animal phyla. Why did this happen? Many paleontologists believe that Snowball Earth was the pressure cooker that forced evolution. The isolation of populations in small refuges may have spurred rapid genetic changes. Furthermore, the massive erosion that occurred during the Great Thaw washed mountains of nutrients, phosphorus, and oxygen-promoting minerals into the oceans. This sudden feast, combined with the oxygenation of the atmosphere, may have provided the energy budget required to build complex bodies. It suggests a poetic and humbling truth. We might owe our existence to the moment that Earth nearly died. Without the stress of the freeze and the nutrient influx of the thaw, life might have remained simple, microscopic, and stagnant for billions more years. Conclusion: the fragile blue marble, the story of Snowball Earth, serves as a stark reminder of our planet's volatility. We tend to view the climate as a stable backdrop to human history, but geology tells us that Earth is capable of wild, devastating swings. It teaches us about the delicate balance of the carbon cycle, how the shifting of continents and the weathering of rocks control the thermostat of the biosphere. It also highlights the incredible resilience of life. The organisms that survived the Cryogenian period were the toughest, most adaptable ancestors we have. They endured millions of years of darkness and crushing cold to emerge into a new, warm world ready to bloom. As we look at the white caps of Antarctica or the glaciers of Greenland today, we are looking at the remnants of a time when the ice was king. They are the fading scars of the worst winter the world has ever known. Snowball Earth is not just a geological curiosity. It is the opening chapter of the story of complex life. It forces us to ask, is a habitable planet the norm, or are we living in a fortunate, fragile interlude between the ice? The rocks under our feet hold the answer, whispering stories of a white, silent world that waited millions of years for the sun to return. Thank you so much for watching all the way to the end. If you enjoyed this video, learned something new, or simply want to see more content like this, please give it a like and subscribe to the channel. Your support truly helps the channel grow and reach more people. And if you have thoughts or ideas you'd like to share, feel free to leave a comment. I'd love to hear from you. See you in the next video.